So if you're a senior multi-cloud architect, you already know the pain. You're juggling workloads across AWS, Azure, and Google Cloud, and the one thing that probably keeps you up at night is certificates. Well, in this explainer, we are going to cut right through all that complexity. We'll lay out a clean, secure, and automated architectural blueprint for your Kubernetes public key infrastructure. Let's get to it.
Okay, here's the plan. First, we're going to name the enemy, that certificate chaos you're probably living in right now. Then, we'll build our way out step by step. We'll start by pouring the foundation with a single root of trust. Then, we'll branch out to each cloud. After that, we'll get down to securing our actual workloads. And for the final magic piece, we'll put the whole system on autopilot. Let's begin.
All right, section 1. Let's talk about the problem. You know, in a multi-cloud world, identity and trust are they're messy. Each cloud has its own way of doing things, its own identity system, and trying to get them all to agree on a consistent security posture, yeah, it can feel pretty much impossible.
I mean, this is really the fundamental question, isn't it? When a service in your AWS cluster needs to talk to a service way over in your Google Cloud cluster, how do they trust each other? How do you establish a common, verifiable identity that just works everywhere, no exceptions?
Look, the old way of doing this is it's painful. It's a world of manual work, inconsistent policies, and just a constant risk of things getting compromised. What we're designing today is the total opposite, a system that's automated, unified, and secure by its very design. One that gets your team out of the certificate business for good.
Okay, before we start building, let's just make sure we're all speaking the same language here. PKI, that's simply the framework of trust we're creating. And at the very heart of that framework are certificate authorities, or CAs. Those are the entities that are actually responsible for issuing the digital identities, the certificates themselves.
And now it's time to lay the very first stone of our architecture. You know, every strong structure needs a solid foundation. And in the world of PKI, that is the root certificate authority. So I want you to think of the root CA as like the genesis block of your security blockchain. It's the ultimate anchor. Every single certificate we issue, no matter how deep it is in the stack, is going to trace its lineage right back to this one single entity. It is the absolute, immovable object of trust. Now, the rules for managing this root CA are non-negotiable. Because it's so critical, we have to protect it fanatically. I'm talking completely offline, air-gapped, maybe even locked in a physical safe. Its only job, its one and only purpose for ever being brought online is to sign a very limited number of second-tier authorities, which we call intermediate CAs.
So, we've established our anchor of trust. Perfect. Let's move to that next layer and see how this whole thing builds out to our different cloud environments.
You know, the architecture is actually beautifully simple. We bring our root CA online for just a few minutes, long enough to create and sign one intermediate CA for each of our cloud providers. So one for AWS, one for Azure, and one for Google Cloud. And just like that, you have a clear line of authority for each environment. And here's why this is so important. What we're doing is creating firewalls of trust. So if, worst case scenario, the AKS intermediate CA were ever compromised, it wouldn't affect the trust of our EKS or GKA environments at all. The damage is contained. This design principle, limiting the blast radius, is absolutely crucial for robust security. Okay, we've got our root and our main branches. Now it's time to drill down to the leaves of the tree, the certificates that our actual applications are going to use to communicate securely. And here's where you really see the hierarchy in action. The EKS intermediate CA, it has one job, serving pods running in EKS. The AKS intermediate only serves AKS workloads, and, well, you get the picture. We've effectively created a dedicated, trusted authority for minting local identities right within each cloud boundary. Now, let's talk about a really critical detail, the lifespan of these workload certificates. We want to keep them incredibly short-lived. 90 days is a great starting point, but honestly, you could even go down to 24 hours. The logic is so simple. A compromised key with a 1-year lifespan, that's a disaster. But a compromised key that expires tomorrow, that's just an inconvenience. This rapid, automated rotation is a massive security win. But of course, manually rotating thousands of certificates every 90 days, that's a non-starter, right? That's where automation comes in. So let's talk about the engine that makes this entire architecture run smoothly, cert-manager. The flow is just seamless. When a new pod spins up, it simply requests a certificate. Cert-manager, which is running in your cluster, catches that request, goes and talks to the right intermediate CA that you've already configured, and boom, it delivers a fresh, valid certificate to the workload. All of this happens automatically in seconds.
So what's the payoff? Well, the benefits are huge. First, you eliminate the #1 cause of certificate-related outages, human error. No more fat-fingered certs or forgotten renewal dates. Second, you can now enforce consistent security policies absolutely everywhere. And most importantly, you automate the entire lifecycle, freeing up your best engineers from managing TLS secrets so they can actually, build stuff.
All right, let's zoom out and take one last look at the blueprint we've just designed. This is what you can take back to your team and start putting in action today.
If you walk away with anything from this, make it these 4 principles. 1. Start with a single offline root CA. 2. Isolate each cloud environment with its own intermediate CA. 3. Automate everything with a tool like cert-manager. And finally, 4. Enforce short-lived certificates for all your workloads. That's it. That's the blueprint for sane, scalable, and secure multi-cloud PKI.
By implementing this architecture, you solved one of the most complex identity challenges in modern infrastructure, period. So the question we'll leave you with is this. Now that you have a universal foundation of trust, what's the next security frontier you're going to conquer? Thanks for joining this explainer.